Imagine the Earth being struck by a massive asteroid, sending shockwaves of destruction across entire continents. The very thought is enough to evoke images of catastrophic loss and global devastation, something straight out of a disaster movie. But for Neil deGrasse Tyson, a prominent astrophysicist, and other experts in the field, this is not a far-fetched scenario but a very real and looming threat. The reality is that Earth has been living on borrowed time, and it could be only a matter of time before an asteroid or comet crosses our path and causes widespread damage. While we have been fortunate enough to avoid such disasters in recent millennia, the potential danger is always there, silently orbiting in space. In his various lectures and public talks, deGrasse Tyson has frequently warned that humanity needs to take the threat of asteroid impacts more seriously. He believes that while the human race has been lucky so far, that luck is bound to run out eventually. If we do not take the necessary steps to understand, monitor, and prepare for asteroid threats, the consequences could be devastating. Our planet has been impacted by asteroids before, most famously, the event that wiped out the dinosaurs over 66 million years ago, and there is a real possibility that history could repeat itself. But unlike the dinosaurs, we may have the knowledge and technology to prevent such a disaster if we act fast enough. One of the key moments that highlighted the threat of asteroids came in December 2004, when astronomers discovered an asteroid that posed a 20% chance of impacting Earth in 2036. The discovery of Apophis, as it was named, sent shockwaves through the scientific community. Although the asteroid was still years away, and the chances of impact seemed remote, the news raised alarms about the vulnerability of our planet. At the time, most people were unaware of the impending danger, as the world was consumed with the aftermath of the devastating tsunami that struck Asia on December 26, 2004, killing hundreds of thousands of people. The media focused on the disaster, leaving little room for coverage of the asteroid that was also hurtling toward Earth. Despite the distraction, the reality of a potential asteroid impact remained. The chance of an asteroid striking Earth may have seemed unlikely, but the fact that it was even a possibility was enough to make many experts take a closer look at the issue. For scientists like deGrasse Tyson, the discovery of Apophis was a wake-up call. It served as a reminder that Earth is not immune to cosmic threats. Apophis, although not the largest asteroid to come close to Earth, was still big enough to cause massive destruction if it were to impact our planet. Early calculations showed that the asteroid could potentially collide with Earth in 2036, causing a tsunami in the Pacific Ocean that would wreak havoc along the coastlines. If this had occurred, the tsunami could have reached heights of up to 5 stories, causing billions of dollars in damage and thousands of casualties. The sheer scale of the potential destruction made it clear that this was not just a theoretical scenario but something that could become a reality if we were not prepared. Fortunately, further observations and calculations allowed scientists to refine their understanding of Apophis' trajectory. By 2013, astronomers had concluded that the asteroid would pass Earth at a safe distance in both 2029 and 2036, alleviating initial fears of a direct impact. However, this close call served as a reminder that, while we may have dodged a bullet for now, we cannot afford to rest on our laurels. Apophis and other near-Earth objects, NEOs, continue to pose a potential threat, and scientists around the world are working tirelessly to track and monitor these cosmic hazards. Even though Apophis is not considered an immediate threat, its repeated flybys serve as a reminder that we live in a fragile and unpredictable universe. The chances of a direct impact with Earth may be small, but they are far from non-existent. While Apophis is one of the more well-known asteroids due to its close approach to Earth, it is far from the only object that poses a potential danger. Over the years, several other asteroids have been identified as potential threats, though many of these risks have been downgraded after further analysis. For example, in 2011, asteroid 2011 AG5 was initially considered a potential hazard for the year 2040, but later observations revealed that the risk of impact was minimal. Despite the reassurances, the fact that scientists are constantly identifying and monitoring new asteroids is a stark reminder of the cosmic dangers that surround us. In fact, there are currently hundreds of near-Earth objects that are being closely watched by organizations such as NASA's Center for Near-Earth Object Studies, CNEOS. These objects, which range in size from small pebbles to massive space rocks, orbit the Sun and occasionally pass close to Earth. While most of these objects pose no immediate threat, the reality is that many of them could one day be on a collision course with our planet. That is why astronomers are continually refining their calculations and improving their ability to predict the orbits of these objects. The more we know about these asteroids, the better equipped we will be to defend ourselves against them in the future. The truth is that asteroids and comets have been a part of Earth's history for billions of years. The craters scattered across our planet's surface are evidence of past impacts, some of which have had catastrophic consequences. The asteroid that wiped out the dinosaurs is one of the most well-known examples of an extinction-level event caused by a cosmic object. But while we have experienced the consequences of asteroid impacts in the past, humanity has never been in a position to defend itself against such an event. This is where modern technology and international cooperation come into play. Scientists and space agencies around the world are now working together to develop strategies and technologies that could one day allow us to prevent or mitigate the effects of an asteroid impact. One of the most promising developments in asteroid defense is the concept of asteroid redirection. The idea is simple yet powerful. Instead of attempting to destroy an asteroid, which could create more debris and increase the risk of multiple impacts, we could redirect its path using a variety of techniques. These techniques include everything from using the gravitational pull of spacecraft to slowly shift the asteroid's trajectory to more direct methods, such as using nuclear explosions to alter its orbit. The key is to intercept the asteroid early enough to make small, precise adjustments to its course, preventing it from colliding with Earth. NASA's Double Asteroid Redirection Test, DART, mission, launched in 2021, is one of the first large-scale experiments in asteroid redirection. The DART mission targeted a binary asteroid system, with the smaller of the two asteroids being the focus of the experiment. In September 2022, NASA successfully launched a spacecraft that collided with the asteroid, altering its orbit around its larger companion. While the asteroid was still far from Earth, the success of the mission showed that it is possible to change the trajectory of an asteroid with a relatively small impact. This breakthrough has given scientists hope that, in the future, we will be able to push dangerous asteroids out of Earth's path before it's too late. Another promising technique being explored is the gravity tractor method, which involves using the gravitational pull of a spacecraft to gently pull an asteroid off course over a period of time. This technique would require a spacecraft to rendezvous with the asteroid and remain in close proximity to it for an extended period, gradually altering the asteroid's trajectory through the subtle force of gravity. While this method would require more time and resources than a direct impact, it offers a non-destructive way to change an asteroid's orbit without creating dangerous debris. This technique could be especially useful for deflecting smaller asteroids that might not warrant the use of more aggressive methods. Scientists are also investigating the potential use of nuclear explosions to deflect asteroids. While the idea of detonating a nuclear bomb near an asteroid may sound like something out of a science fiction movie, it is actually a serious area of research. The goal of a nuclear explosion would not be to destroy the asteroid but to change its trajectory by applying a burst of energy to its surface. This technique would require careful planning to ensure that the explosion does not break the asteroid into smaller, more dangerous fragments. Instead, the explosion would ideally be used to alter the asteroid's course enough to prevent it from striking Earth. While this method is still in the experimental stages, it represents a last resort option for deflecting large, dangerous asteroids that cannot be redirected using other techniques. Despite the advances in asteroid defense technology, the reality is that we are still in the early stages of developing a robust global defense system. While missions like DART and the ongoing study of near-Earth objects have provided valuable insights into the nature of asteroid threats, there is still much work to be done. One of the biggest challenges is developing a system that can quickly detect and track potential asteroid threats in real time. As the technology continues to improve, space agencies around the world are working together to build a global network of telescopes and monitoring systems that will allow us to detect asteroids long before they pose an immediate danger. The ultimate goal is to have a fully integrated global asteroid defense system in place, one that can respond quickly to potential threats and provide an effective means of deflecting or mitigating the impact of a dangerous asteroid. This system would rely on a combination of technologies, including asteroid tracking, redirection methods, and early warning systems, to ensure that humanity is prepared for any eventuality. But, as with any global initiative, cooperation among nations will be essential. In a world where geopolitical tensions often divide us, the need for a unified approach to asteroid defense is a rare opportunity for international collaboration. While we have made significant strides in asteroid defense technology, it is important to remember that the threat is not going away. Asteroids and comets continue to orbit our solar system, and some of them will inevitably come close to Earth. While we may not be able to prevent all potential impacts, the progress we have made in detecting, tracking, and redirecting asteroids offers hope that we will be able to protect ourselves from future threats. The key to survival lies in our ability to recognize the threat early, develop the right technologies, and act swiftly when the time comes. And while the odds of a catastrophic asteroid impact may be low, it is a risk that we can no longer afford to ignore. As we look to the future, the reality is clear: asteroid impacts are a threat that we must take seriously. Whether it's a small asteroid or a giant comet, the potential for catastrophic damage exists, and we must be ready to defend ourselves. Thanks to the efforts of scientists, space agencies, and international collaborations, we are better equipped than ever before to deal with the risks posed by near-Earth objects. But the question remains: when the time comes, will we be ready?